Hello, everybody. In today's lesson, we're going to start with lesson 5.2, Finding Unknown Numbers. We're on page 193 of your third grade textbook. And our essential question today is, how can you use an array or a multiplication table to find an unknown factor or product? All right, so let's look at the unlock the problem. Tanisha plans to invite 24 people to a picnic. The invitations come in packs of 8. How many packs of invitations does Tanisha need to buy? So I need to use 24 people. That's how many total we have. And I need to buy packs of 8. So how many packs of 8 does Tanisha need to buy to reach 24? So how many people is she inviting? 24. How many invitations are in one pack? 8. So we're going to use something called an equation. And an equation is a number sentence that uses the equal sign to show that two amounts are equal. A symbol or letter can stand for an unknown factor. You can write the equation n, some unknown factor, times 8 equals 24 to find how many packs of invitations Tanisha needs. Find the number n that makes the equation true. So in our equation, the 8 represents the number of invitations per pack, and the n, the unknown factor, represents how many packs we need. And then 24 is the total number of invitations that shows she's going to need because she's inviting 24 people. So one way we can solve this unknown for an unknown factor is to use an array. Okay, and so we know that there has to be 24 total, and we know that each package has 8. So let's make rows of 8 until we get to 24. And so it says show an array by completing the drawing. So let's add another row of 8. Okay, so 8, 10, 12, 14, 16. So I haven't got to 24 yet. Let's see if we can add another row of 8. 17, 18, 19, 20, 21, 23, 24. Okay, so yes, we got to 24 that way. So the unknown factor is represented by the number of rows because we have 8 in each row and we have 3 rows of 8. So since there are 3 rows of 8 tiles, the unknown factor is 3. N equals 3. 3 times 8 does equal 24, so the answer checks. And when we say 24 equals 24, and the equation is true, what we're saying is the left-hand side, 3 times 8, is 24. So 24 does equal 24. So she needs 3 packs of invitations. All right, so that's one way we can use an array. Page 194. Okay, use a multiplication table is another method. And so here we know 3 times 8 equals what? Well, we find where 3 going down and 8 going across, where do they intersect? The 3 and the 8 intersect at 24. So it says find the product 3 times 8 where row 3 and column 8 meet. The unknown product is 24. Okay, so 3 times 8 equals 24. 24 does equal 24, so the equation is true. All right, what is the unknown factor shown by this array? 1, 2, 3, 4, 5. So we have 5 rows of what? 1, 2, 3, 4, 5, 6, 7. 5 times 7 is 35. Let's see. 5, 10, 15, 20, 25, 30, 35. So 5 times 7 equals 35. 35 equals 35. So the equation checks. Find the unknown number d times 3 equals 27. Okay, well, ideally, we would know our 3 times tables, and we'd be able to just know what that missing number is. But let's practice the arrays. So number 2, I'm going to use scratch paper for this. Okay, and so I'm going to keep adding rows of 3 until I get to 27. Okay, that's 6, 9, 12, 15, 18, 21, 24, 27. So we have 3 in each row. How many rows do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So our unknown factor is 9. 9 times 3 equals 27. So 27 does equal 27. All right, 6 times 5. In this case, again, I could draw an array of 6 rows of 5. But it's just as easy in this case to count 6 fives if I don't know what 6 times 5 is. I could use the multiplication table, 6 rows of 5, and it meets at 30. So this type of lesson you start to realize how important it is really just to know our multiplication facts. All right, number 4, 5 times 4. Let's go ahead and I'm going to draw an array. If you know what 5 times 4 is, write the answer. All right, so number 4, I'm going to use scratch paper. And I have 5 rows of 4. All right, so there's my 5 rows of 4. And that doesn't mean I have to count by 4s. I can count by 5s. 5, 10, 15, 20. All right, what number times 2 is 14? Okay, if you know the number times 2 that equals 14, write your answer. All right, so I'm going to have some rows of 2 that equal 14. So 2, 4, 6, 8, 10, 12, 14. 1, 2, 3, 4, 5, 6, 7. I have 7 rows of 2. So 7 times 2 equals 14. And 14 equal 14 is a true equation. All right, 4 sets of 9. Well, again, we could use a multiplication table. We could just know what that math fact is. We could use 9 times 2 doubled. Okay, so we can use all the strategies we've learned for multiplication to do this problem. We could break 4 times 9 into simpler problems by using the distributive property, 4 times 5 plus 4 times 4. Okay, or we can continue to practice the arrays as this lesson is showing us. So 4 times 9. So we have 9 in each row this time. So what would be faster, just knowing 4 times 9 or making an array every time we have to do a multiplication problem? Hopefully you say just knowing it. So we got to put some time into memorizing our math facts. Okay, you can use flashcards, have somebody quiz you, whatever it takes to memorize those math facts. Okay, so I have 4 rows of 9. Okay, now I've got that drawn. Now I have to add them, right? Huh, I guess I should have just known what 4 times 9 is. 9 and 9 is 18. 18 and 9 is 27. 27 and 9 is 36. Okay, so 4 times 9 is 36, which makes that a true equation. 8 times something is 64. 8 times something is 64. Well, so if you know what 8 times something equals 64, obviously just write that answer. What is the unknown factor? If you need to draw the array, go ahead and start making it. Okay, I know it has to be 8 rows of something. 8 rows of something. All right, so 8, 16, 24, 32, 40, 8, 16, 24, 32, 40, 48, 56, 64. 8 rows of 8. Okay, and again, so that takes a lot longer to do that type of math problem. 8 times something is 64. 8 times 8 is 64. So the unknown number is 8. Okay, so I made my 8 rows of 8. I went rows first and then counted across. 7 times something is 42. Well, I know 7 times 5 is 35. If I add one more 7, 35 plus 7, 35, 36, 37, 38, 39, 40, 41, 42. 7 times 6 is 42. So 7 times the star equals 42. 7 times 6, 42. 42 does equal 42. All right, 8 times 9. So if we were using the multiplication for table for this, we'd find 8 rows. We'd go down to the 8th row. We'd find the 9th column, and we would see where they meet. And they meet at 72. So 8 times 9 equals 72. Times 9 equals 72. And they check each other. All right, number 10. 9 times 2. Okay, now I'm not going to draw an array for that one. That is a basic, simple math fact. It's also easy to just count forward on that, or to just add 9 twice. 9 twice is 18. $28 equals 4 times what? Okay, in addition to arrays, we can skip count. Okay, let's try that this time. 4 8, 12, 16, 20, 24, 28. So we added 1, 2, 3, 4, 5, 6, 7 fours. So 4 times 7 is 28. Some number times 3 is 9. We'll count 3 times what is 9? 3. 3, 6, 9, right? 7 times 9 equals some unknown product. 7 times 9. Well, I know 7 times 10 is 70. So if I take away 110, 70 take away 7 is 63. So 7 times 9 equals 63. Okay, why did I subtract 7 there? Because I used the distributive property and I changed 7 times 9 into 7 times 10 and then subtracted the extra 7 that I added. 5 times some number is 40. Okay, I'm not going to draw an array for this one. If in worst case scenario, I can count by 5s easily to 40. Okay, I know that 5 times 6 is 30. So I need 2 more 10s, so that's 8. 5 times 8 equals 40. Some product equals 8 times 7. Okay, so if we had to draw an array for that, for number 15, we'd have 8 rows of 7. Obviously, if you know what 8 times 7 is, you would write the answer. Okay, and again, you see how much longer it takes to draw an array to have to figure out what 8 times 7 is. Okay. So I've drawn an 8 by 7, but I still don't know what the answer is, right? Now I still have to add. It would have been so much easier just to know what 8 times 7 is. All right. 7 plus 7 is 14. 14 plus 7 is 21. 21 plus 7 is 28. 28 plus 7 is 35. 35 plus 7 is 42. 42 plus 7 is 49. 49 plus 7 is 56. Yeah, I think it would have been easier just to know 8 times 7 is 56. Some number times 6 is 36. 6, 12, 18, 24, 30, 36. I skip counted 6s 2, 4, 6 times. So the rhombus is 36. 8 times something is 72. 8 times something is 72. Okay. So if we had use of a multiplication table, we'd go to 8 rows, the 8th row, and we'd go across until we found 72. Okay, I found 72, and then I would go up to the ninth column. So it's 8 times 9. Nine times what is 27? 9 plus 9 is 18. 18 plus 9 is 27. So 3. 9 times 3, 27. 6 times 10 equals some product. Okay, no need to do an array for this. No need to use the multiplication table. You should know 6 times 10 is 60. Two times 5 is some number. Okay, 2 5s. 5 and 5 is 10. 10. 32 equals 8 times some unknown factor. So how many 8s would it take for us to get to 32? Well, we could draw an array and have 8 rows of something. So it would be 8, 16, 24, 32. So I'd have 4 in each row. Eight, 16, 24, 32. I counted 4 8s. 6 times 4 is what? Okay, I'm going to revert to previous chapter and know that 6 times 4 is the same as 6 times 2 doubled. So 6 times 2 is 12, and 12 plus 12 is 24. Seven equals 7 times some number. 1. 1 times any number is the other number. Some number times 3 is 15. 3, 6, 9, 12, 15. 5. 8 times 6 is some product. Well, we know that 8 times 5 is 40. So if I add one more 8 to 40, I'd be at 48. All right, find the unknown number. 3 times 6 equals k times 9. Well, what is 3 times 6? Well, 3 times 6 is the same as 3 times 3 twice. 3 times 3 is 9. Double that, that's 18. So 18 equals k times 9. How many 9s does it take to equal 18? 2. 2 times 9. So k has to be 2. 4 times an unknown number equals 2 times 6. 2 times 6, we know that's easy. That's 12. So 4 times something is 12. 4, 8, 12. 3. 4 times 3 equals 12. 5 times something equals 36 minus 6. 36 take away 6 is 30. So 5 times an unknown factor is 30. How many 5s does it take to get to 30? 5, 10, 15, 20, 25, 30. 6, right? So 5 times 6 is 30. 36 take away 6 is 30. 6 times 4 equals something times 3. All right, 6 times 4 is the same as 6 times 2 doubled. 6 times 2 is 12. 12 and 12 is 24. So we need to come up with some number times 3 that's going to give me 24. 3, 6, 9, 12, 15, 18, 21, 24. 8. 8 times 3 is 24. 9 times something equals 70 plus 2. 70 plus 2 is 72. Well, earlier we did a problem where we had 8 times something is 72. So 8 times 9 is 72. 9 times 8. 8 times something equals 60 take away 4. 60 take away 4. I can't take 4 from nothing, so I'll regroup one of the 10s as 10 ones. 10 take away 4 is 6, so 56. 8 times what is 56? 8 times what is 56? Well, I know 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. So 7. 8 times 7 equals 56. All right, 32. Invitations cost $3 a pack. Oh, sorry, $3 for a pack of 8. Lori gives the cashier $20 to buy invitations and gets $11 in change. How many packs of invitations does Lori buy? Explain. $3 for a pack of 8. She gave the cashier $20 and got 11 back. So basically we're saying 20 minus 11. So she gave the cashier $20. She got $11 back. That'll tell me how much she spent. And then I can go 3 times some number equals that. So 20 take away 11 is 9. 9 plus 11 is 20 equals 3 times something. 3, right? 3 times 3 equals 9. So n equals 3. She bought 3 packs. Okay, so if 20 take away 11 is $9, she spent $9. She had to buy, each pack cost her $3. So how many packs did she buy if she spent $9? 3, 6, 9. She bought 3 packs. All right, 196. Tanisha needs, use the table for 33 through 36. Let's make sure we understand our table first. So we have picnic supplies, and we have these different items: bowls, cups, tablecloth, napkins, and forks. And these are the number in each of the packs. I'll get 6 bowls per pack, 8 cups per pack, 1 tablecloth per pack, so on. And these will be the costs per pack. So for every 1 pack of bowls, it costs $10. For every pack of cups, $3. Okay, so on. She needs 40 cups for the picnic. How many packs of cups should she buy? Okay, well, there's 8 cups in a package. So if we were writing a math equation, it would be 8 times some number equals 40, where the n is the number of packs. So 8, 16, 24, 32, 40, 5, 5. 8 times 5 is 40. So our unknown number is 5. She needs to buy 5 packs of cups. All right, 34. Miss Hill buys 3 tablecloths and 2 packs of napkins. How much money does she spend? 3 tablecloths, 2 packs of napkins. How much does she spend in all? 3 tablecloths. Each tablecloth is $2. So we're going to go 3 times 2 plus the 2 packs of napkins. 2 packs of napkins is $2. Okay? So 3 tablecloths at $2 a tablecloth. 2 packs of napkins at $2 per pack of napkins. So 3 times 2 is $6, plus 2 times 2 is $4. She spent $10 total. $35. What if Tanisha needs 40 bowls for the picnic? Explain how to write an equation with a letter from an unknown factor to find the number of packs she should buy, then find the unknown factor. So she needs 40 bowls for the picnic. So since there is 6 bowls per pack, she would need some number of packs times 6 to equal 40. Okay, so it would be n times 6 equals 40. Well, something times 6. 6, 12, 18, 24, 30, 36, 42. I actually don't say 40 when I count by sixes. So I can't, if I buy 6 packs, I'd be at 36. That's not enough. So if I have to have at least 40 bowls, I'm going to have to buy 7 packs. 6 packs is not enough. So she needs to buy 7 packs of 6 to have 40 bowls. Okay, she actually have 42 bowls, but if she needs 40, then she needs to buy 7 packs. What if Randy needs an equal number of bowls and cups for his picnic? How many packs of each will he need? He needs an equal number of bowls and an equal number of cups. Okay, so here's the idea of we need to find a common, what we call multiple. So if we skip counted forward by sixes, if we make a list of sixes, 6, 12, 18, 24, 30, okay, we can stop there. All I'm doing is counting by sixes. He needs the same number of bowls and cups, okay? So this is 1 pack of 6, 2 packs of 6, 3 packs of 6, 4 packs of 6, 5 packs of 6. Now the cups would be in groups of 8, so 8, 16, 24, 32, 40. Do we have a set where they match? Yeah, 24. Okay. How many packs will he need to buy? He would need to buy 4 packs of bowls and 3 packs of cups. Okay, so let's make sure we understand where I got these from. 4 packs of bowls. Each pack of bowl comes in packages of 6. So 6, 12, 18, 24. So I need 4 packs of bowls to equal 24. And I need 3 packs of cups because they come in packs of 8. 8, 16, 24. So I need 3 packs of cups. And 4 packs of bowls. All right, for 37A through 37D, choose yes or no to show whether the unknown factor is 8. Is 8 times 8 64? Well, if we go back to our multiplication table, and we find 8, and then we find 64, there's 64, go up the column, and I see that it's at 8. So 8 times 8 is 64. So yes. Is 8 times 3 27? Well, let's look in the row of 8, and as I go across, I don't see 27. So no. 8 times 3 is not 27. 8 times 3 is 24. 6 times 8, 42. Let's see. Let's go in the row of 6. And if I go 6 times something, do I get 42? There's 42. Is that times 8? No, it's times 7. 6 times 7 is 42. So that's also no. Is 8 times 7 56? So here's 8. Let's find 56. Go up. 8 times 7 is 56. 8 times 7 is 56. That is true. Okay, so let's look at these again. 8 times 8 is 64. 8 times 3 is not 27. 6 times 8 is not 42. 8 times 7 is 56. All right, so that's it for lesson 5.2. In our next session, we'll be talking about the mid-chapter review. So until then, may the numbers always be in your favor.